Hey, welcome back. So in the last video, we have built a LabView program that basically program the amount of water that has got into the tank, the same exactly like the one that we have programmed in MATLAB. So our program can show how much volume of water got into the tank and how much of the water, it basically shows if the tank has been overflowed or not with an LED light bulb here. So now we're going to continue building this program like we did for MATLAB, but this time we want to know if the tank is overflowed, how much of water has been overflowed, and if it has not yet been overflowed, how much time do we have left to stop the pump. So going back again to the question, here was the question. The question that we solved for MATLAB was that at different time points, whether the tank was overflowed, and if the tank is overflowed at each of these time points, how much of water has been overflowed, and if the tank is not overflowed, how much time do we have left to stop the pump and prevent tank overflow. So we know that that V empty, or the volume of the head space in the tank, is the total volume minus the initial water in the tank, and we know that when the tank is overflowed, the time to stop the pump is V empty minus the volume of water that got into the tank divided by the flow rate, and so on. So we're gonna keep this in mind, or this equation, and we're gonna start building up our program. So okay, so this question is that if the tank is overflowed, how much of water has been emptied from the tank, and if the tank has not been overflowed, how much time do we have left till we stop the pump to prevent tank overflow. So you can see that we have this if this happened, then what. So the if statement and all these things should be found in the block diagram, because this is that the programmer made and the user, they don't care. So we right click here and we go to the structures. In the structures is where you can find all these, if clauses, for loop, and while loops, and so on. So if clauses in MATLAB, in LabView, they are called case structures. So you click on case structures and you can see that this is interactive. So what I'll do is that I'll just open a box here. Inside this box is my case structure. So notice when this box is open, we have a true and a false. So we are in the true window right now. You can click in here and go to the false window. So whatever you put inside the false window is what will happen if a certain constraint is false. And whatever you put in the true window is what the program will do if a certain constraint is true. So what is our constraint here? Whether the tank is overflowed or not. If the tank is not yet overflowed, how much time do we have left to stop the pump? And if the tank has been overflowed, how much of water has been overflowed from the tank? So we have a true or false here, right? So something has to be connected here. So in the case structure, as I showed you, we have a true and a false, and we have something which is called a case selector, which is our constraint, is our true or false, that has to be connected so that the case structure windows knows to go to the false window or to the true window. And what is our case? What is our constraint here? Our constraint is this: is the tank overflowed or not? So we have to wire this to here. Notice if I don't wire this, you can see that the run button is crushed, so there is an error. So if I click on it, left click on it, it will show to me that the case structure must have a boolean, numeric or enumerated input wired to its selector terminal. So this is the problem. This is the selector terminal, which has not been connected to anything. So the program is ill made and we have to fix it. Otherwise, we cannot run our program. So we know that the Boolean here is this: is the tank overflowed or not? So if the tank is overflowed, yeah, if it is a yes, we are in the true section. Then what? So in the problem, we had that if the tank is overflowed, find me the overflowed volume of water, and which is VF minus V empty, or the total volume of water that got into the tank minus the tank headspace. So what we need is a minus sign, right? A subtract function. So we choose the subtract function here and put it inside the true window because the tank is overflowed and we want to measure something that we want when the tank is overflowed. And it is that the volume that got into the tank, the volume of water that got into the tank, which is this one, right? Which is the flow rate multiplied to time. And it goes to the y, I guess, right? Because here in the equation, no, it goes to the x, sorry. It's VF minus VMT, I'm sorry. So we'll have to delete this. So this is actually good because I can show you something. I have to delete this because I have to connect it to the x because it's VF minus VMT. So if I want to delete this, if I delete this part and doesn't delete this part, there will be a cross, so I'll delete this part too. Sometimes there is this block here that remains when you are deleting. It just stays. Right now it's deleted, but if it stays, make sure to delete it because it's something that is there and doesn't do anything. So you don't need that block there if it's not connected to anything. But here the x is as our VF, so we connected it to our VF. It didn't connect it right. So okay, right now it can go anywhere. Like it can be like this, it can be like this, like it doesn't really matter because the length of the wire, as I said, is not important. It's just that from where to where it is connected, that's the important. It doesn't matter which path it takes to connect or how long it is. It just doesn't matter. It will send the data anyway. And anyhow, it doesn't matter. So, but you want your program to be clean. You don't want a lot of wires like passing through the paths that are not necessary. So it doesn't matter how you connect it, as long as this X is connected to our volume of water that got into the tank, it's important. Notice there is another cross here, so I'll click on it, and it's talking about this subtract button here. Like when I double click on it, it will jump to the section that the error is, and it will show you that the error is in the subtract. So we are missing a y and we are missing the results. So that's the reason. So VF minus VMT, and VMT was the current headspace of the tank. I guess we haven't defined the headspace here yet. So what is the headspace? The headspace was the total volume of the tank minus the current amount of water in the tank. So we have to find the initial headspace of the tank before we start turning the pump to add water, to know how much initial headspace of the tank we had and how much water we have added so far, to know how much of the tank has been overflowed. So so we need another subtract here. So we go to numeric to subtract, and we say the total volume of the tank minus the initial volume of the water in the tank is basically our initial headspace. And then whatever volume of water that got into the tank minus the initial headspace of the tank is going to give us the amount of water that has been overflowed. So right now we have the X and we have the Y, and we want to subtract them. So we right click here and say create an indicator. And we call this is an indicator again, because this is something that the user will see. User has no control of it. It's just the results, and the user is going to see that. So we are going to call this volume of water overflowed from the tank. And notice that our run button is now okay and it's white. So we don't have any problem building this program. So we can run our program now. I'm gonna move this and bring it here so you can see better. Okay, so let's run it. Initial volume of the water in the tank was 5 liter. Total volume of the tank is 20 liter. Flow rate is 2. And we're gonna type different time and we're gonna see what happens. So we know that at 9 minutes the tank will overflow. So I'll type 9 here and then I'm gonna run. It says that the volume of water that got into the tank was 18, which is right. 9 multiplied to 2 is 18. Current volume of the water in the tank that the tank can actually hold, not that all of them, not that all this volume the tank could hold, but the total volume of the water that passed inside the tank is 23, which is 18 plus 5. And the volume of the water overflowed from the tank is 3, because the tank volume is 20 and we have so far added 23 volume of water, so 3 of it will be overflowed. There's another way that you can define the volume of the water that has been overflowed, and it's just to subtract this current volume of water 23 minus the total volume, and that will also give you the same results. Your mathematics is better than me, so you already know that doesn't matter how you define it, it will give you the same results as long as you know the equations are right. So this part was the true part, which is the part that says that if the tank has been overflowed, how much of water has been overflowed. We have another statement, and the other statement is saying that if the tank is not overflowed, how much time do we have left till we stop the pump? And from the equation, we know that this time is basically the initial empty volume of a tank, or the initial headspace of a tank, minus the volume of the water that gets into the tank divided by the flow rate. So we keep this equation in our mind and we go and build our LabView program. So this time we have to go to the the false window, because this time the tank has not been overflowed. So you could either click in here and go to false, or you could just click on this arrow and go to the false window. So in the false window, we know that the tank overflowed. The results will be false this time. And we want to know how much time do we have left to stop that pump. So this time, we need a V empty minus VF. And a V empty we know is this line, right? Because you can just notice like these two squares here. In the true window, they have been connected to something, but into the false window, they are not connected yet. It doesn't mean that you have to connect them, no. As long as they are connected in either the true window or to the false window to something, they're okay. But you don't want them there without being connected to anything at all. So you're not forced to connect them in the false window to something. As long as they are connected in the true window, it's okay. So in the false window, we have V empty minus VF, and we know that this is our V empty. Why? Because it's the total volume of water minus the initial volume of the water, and that V empty is the initial headspace of the tank. So we right click here again, and we again need to use a subtract because we have V empty minus VF. So we put it here. You could either do it like this and connect it and create another square here, or I'll Control Z it, or you can just connect this to here and have your program cleaner. It doesn't really matter, it will give you the same results, but this way you'll have less wires connecting to other things, and it's just a cleaner program. So that's my VMT, and we know that our VF is actually the volume of water that got into the tank. So you could connect this again to this wire. And the result of this subtraction has to be divided by the flow rate. So again, right click, numeric, and this time you'll use a division, like a function. And the results of it has to be like, this is x divided by y. So the results of this subtraction will be divided to the flow rate. And this is our flow rate, right? And here again, you have to create a what? An indicator. So right click, create an indicator. Why? Because this is again something that the user will see as a result. Time to stop the pump. I can write time left to stop the pump. And again, if you cannot find it in the front panel, you can click it and you can double click on it, and it will show you where it is, and then you can move it and make it clean and all these things. So now you can see the run button is white and it's clean, so we can run it. So now here, if I run this again, it shows us that during the true section we have 3 volume of water that has been spilled. But now let's go to the different situation, a 5-minute one. If I run this, it says that this will be turned off. That means the tank is not overflowed, and it shows you that the time left to stop the pump is 2.5 minutes. But here you can see that the results from previous run is still showing here. So it still show you a 3. So maybe when a user come and see this, she'll get confused, because she'll say that the light LED is off, so it means that the tank is not overflowed. And here I can see that the tank is not overflowed, and here it's telling me that I have 2.5 minutes left to stop the pump to prevent tank overflow. But how come this is showing me that I have 3 liters of water overflowed? So it might be confusing. Why? Because this is showing from previous run. All these things has been overwritten. 1, 2, 3, 4, 5. They have all been overwritten, but this hasn't been overwritten. It just stays from previous. So I'm going to show you a trick that you can make it like 0, and so that every time you run, these values will go to 0 and it will not confuse a user. There might be a better tricks, but this is the one that I know and I have came up with. But if when you're Googling or doing something else, or if you have the knowledge of how to make this reinitialize the program, please let me know. You will have an extra mark actually. But right now I'm going to show you how to do that. So I'm going to make this window a little bit larger so you can see better now. Okay, so there is when you right click in the function, in the structures there is something called a flat sequence. So I will click on the flat sequence and I will put everything inside a flat sequence. So what a flat sequence means, that it has the name in it, it's sequence. It means that a certain program will finish in this window first, then it will go to the next window and run another program. And when that program is finished, it will go to another window and run the other program. So basically, when you add a flat sequence, everything doesn't run at the same time. It will give them a sequence of time to run a program. So here I've put the entire program in the flat sequence, and if you click that flat sequence and then right click and say add frame before, it will add another frame for you before this flat sequence. What it means is that it will run this part first and then go to next part. So what I want to do is that I want my volume of water overflowed from the tank and the time left to stop the pump to always be 0 at first. So because both of them at the same time cannot have a number. The tank either overflowed or not. So if it's overflowed, we know how much volume has been overflowed, and it hasn't been overflowed yet. We know how much time we have left to stop the pump. So we want either of these number to have a number, either of these variables to have a number, and the other one to be 0, so that the user will not the user is not confused with the results. So it's the time left. So the two variables are the time left to stop the pump and the volume of water overflowed from the tank. So I'm going to show you a little trick here. If you right click on the time left to stop the pump, select it and right click and go to create, then go to property node and then go to value and click and put it here. So basically what it does is that it will create the exact same control indicator for you here without adding another one of them here. So you'd only see one indicator in the front panel, however you see two of them in the block diagram. This is extremely useful for you when you are building your program as we move forward. Why? Because this way you don't have to wire a ton of things to this variable, not a variable, an indicator actually, and you just have a cleaner program. It's much easier to follow and it's not confusing. So for example, so far I have wired everything that I wanted from here to there without defining basically a value of the property node, like redefining the same indicator. Because this program is not huge. But as we move forward, your program might get bigger and bigger and larger, and for some reason you will have something, for example, build up here in your window, and then later you want to use it like here, somewhere in here in your window, and you don't want a big wire, like wiring things together, because it will get really confusing and not clean, and it's hard for you to follow. So this way you'll just define by right-clicking, create, property node and value. So you redefine your value, either your control or your indicator. That basically what it means, that it has the same value of this, and you can just define it, and it's just so easy, because then you don't have to wire them when they are so far away from each other. You can just redefine the value, and that put the value over in the location that you want to use it, and then wire it to whatever you want. So when you run this program, you will understand it better. So, and then if I right click, select it, and then right click on it, I can change it to right. So when you change it to right, it means that it's actually like an indicator, like you can write on it. Like you can see this wire is getting into an indicator, so it's gonna write in the indicator, so it's sending signals to an indicator. But on the other hand, like if I right click and say change to read, it means that it will send signals out and it will read it for you. In this case, we want it to be as a write, because we want it exactly to be like our indicator. So I will delete this wire, move this in here, and use this and actually wire this to this. So basically I didn't do anything different. What I did was that I redefined the same indicator here, and I connected the results of the time left to stop the pump to the redefined indicator, not to the first one that we defined. Why? Because I want to give a value of 0 to this indicator at first. So at first this indicator gonna read 0 in this first window of the sequence, and as it gets inside the program, it will redefine that value. So this is how it does it. So in the first window, you right click to numeric and you go to DBL numeric constant. So this way you can define a value of 0 for your indicator. You can type any value that you want in here, like I can type 10, But for this specific problem, I want this to be 0 because I want to 0 it at first. And then I connect 0 to this. So you notice that this numeric that I defined, like this is a control. You can see that the signal is getting out of it. And then, so this is a control, a signal gets out, but this is an indicator, a signal gets into it. We have the same situation here for the volume of water overflowed from the tank. Again, you right click on it, select it, go to create property node and then value. Put that here. This is exactly like this. It's exact same thing. So again, I'll delete this. I'll take this to here. And you can see, because this is larger, this window just stretches and gets bigger so that it will, it can hold everything in. This is a good thing about LabView. It's so interactive. Now, if I don't change this to write and just keep it as a read or as a control, notice that I cannot connect these two wires to each other. There will be an error. Why? Because this needs to send signals out because that's a result. And this, in this current format, sends signals out too. You cannot connect two things that send signals out. You can connect one thing that sends signals out and the other thing that reads the signals. When you see this error, you will definitely know. And again, you can see here, we have this problem here. A wire must be connected to one and only one data source, such as a controls terminal or function output. So this is basically giving you the information. So what you can do is that you can right click and go to change all to write. And when you do that, it's basically even fix this wire. So this is good. Now here we want to connect this also to 0. You could either define another 0 here and connect it, or you can have your program a little cleaner and then connect these two to 1, 0. So now let's go to the front panel. And now if I run this, like for this case, the water should not be overflowed. So then notice this number here. See, now this is 0. Why? Because at first it goes to here and make it 0, all those two variables, and then come to here and start running the program. Now if I type like 9 in here and then run it, you can see this time this is 0, and this is giving us the volume of water that has been overflowed, which is 3. So if I turn on the light bulb here, you can see how this is running. So at first it comes here, give these two variables 0, then goes to the next sequence. And for example, for this specific case, this will be true, this value, and it will go to the true section and then run it. This is interesting. This is one thing that I wanted to give you. There are two other things that I want to show you. So this flat sequence, you saw that, right? So one window and then next window. You can have another window afterward. If you say that you don't want like window and make your program huge, there's another way that you can do that. You can right click on it and say that replace this flat sequence with stack sequence. And when you right click on it, this is what it will give you. So now it's a stacks of sequence rather than a stretch of a sequence. So in the first window, this is what you will see. And you can either right click here and then go to the second window, or with your arrow, you can change the windows. So now you can stack the sequences and have them like running based like 1, 0, 1, 2, 3, and so on. And the result, I mean, the programming results shouldn't change. It will give you the same thing. Like, again, if I type 5 here, oh, because the light is on, it's going to take a while for it to run. But, so this time, notice that it will go to the false window. I'll turn this off so that it will run fast. So now you can see that this time this is 0 and we have 2.5. But if I type 9 here, this time this is 0 and this is 3. So it doesn't really matter. I'm gonna save this program and save it as. So when you are saving it as, there are several different like items and icons that you can choose. I always use the first one because this way I can rename my program and keep the original program too. So you can also always do that too if you want to make a new program, a new program, a new program. Oh, it says there's another one there. Tank with case structure. I'll just name it like this. Okay. So this is one thing I want to show you. There's another thing that I want to show you, but I think the video will get large and it's going to be hard for me to save it. So I will show you in the next video. Sorry. See you later.